Okay, so this lesson is on evaluating algebraic expressions using substitution. So the first thing we're going to do is define what substitution is. Substitution is when you replace a variable, which is the letters, with a number. So these are like formulas and things that you have seen where there's letters in the formula and you replace it with numbers to get what you actually want. We're going to start with a story problem. Eric collects miniature cars. He has one large case that has 20 cars. He also has 3 same-size, smaller cases filled with cars. Let n equal the number of cars in each smaller case. Write an algebraic expression to represent the number of cars Eric has. To make sense out of this, I'm going to draw a little picture. So I'm going to draw the bigger case, and it has 20 cars in it, so I'm going to label that with 20. And then he has 3 smaller cases, and we don't know how many is going to be in each case, so that's what the variable n is for. So we're going to call this n and n and n. So when we write our algebraic expression, we know that there's 20 cars in the first case, plus there are 3 cases with n, which is our unknown amount of cars in each. And so we would write that as 3n, just to represent the 3 cases that each have an unknown amount of cars. Okay? And then when it asks this question, how many miniature cars does Eric have if each smaller case holds 10 cars? Let's do that one first. We can actually use this formula, 20 plus 3n. And where this n is, we're going to put in the 10. This is called substitution. So I'd have 20 plus 3 times 10. And I like to use parentheses when you have the variable right next to a number like this. That helps me realize that this is multiplication. You could also use the little multiplication dot. All right, so now we need to think about order of operations. I have multiplication here. I have addition here. And so if we think about order of operations, we're supposed to do multiplication first. So 3 times 10 is 30. And then we can go ahead and then add the 20 plus 30 to get 50. So that's 50 miniature cars. Now the nice thing about writing this algebraic expression is it's like a formula no matter how many cars we put in there. So I'm going to do 12 cars next. And it's the exact same process, 20 plus 3 times 12. I still do the multiplication first, so 3 times 12 is 36. And then I add that to the 20, and in that case I would have 56 of those little miniature cars. And then there's one more. It also asks, okay, what if I change it to 14 cars? Well, I still have the 20 in the big case, plus 3 little cases that would then have 14 cars in each. And so same thing, 3 times 14 is 42. If I add that to 20, then I get 62. Now one thing that you often see when you write a formula like this is they will organize the information in a table. And so you'd put n for your unknown. And so in this case we tried making n 10 cars, and then we made it 12 cars, and then we made it 14 cars, and you could make it pretty much any number that you want. And so this is why we call these variables, because n could represent a lot of different numbers. What n represents will vary, it will change. On this side, we would put our formula, 20 plus 3n. So these numbers over here are what we would call our inputs. This is an input-output table. These are the numbers that we're putting into our formula. And then over here is where we're going to get the outputs. So when we put in 10, we got 50 out. When we put in 12, we got 56 out. When we put in 14, we got 62 out. So these are the outputs. So the numbers that they give us are the inputs. That's what we put into our algebraic expression. And then these are the numbers that we got as our answer. So that's our outputs. All right, so now we're going to look at some more generic problems. So if you need to do some more with number 2, you can stop the video now and look at that again or rewind it. So I'm going to go down to number 3. So it says evaluate 4x plus 8 when x equals 2, 5, and -1. So these all are our inputs that we're going to put into the formula. And they're going to go in where this x is. X is going to be 2, and then x is going to be 5, and then x is going to be -1. So the first one we're going to do is 2. So you take 4x plus 8, we're going to take the x out, and we're going to put in 2. So when the x is right next to the number like that, these are going to get multiplied. And that's why I like to use parentheses just to separate it. Otherwise it looks like 42, which is not what we're looking for. All right, so we do the multiplication first. 4 times 2 is 8, and then 8 plus 8 is 16. So that's my first answer. Then I'm going to put in 5. So I'm going to go in a nice orderly fashion from left to right. I'm going to do 4 times 5, which is 20, and then plus 8, which is 28. So you always want to do multiplication before addition. That's just our order of operations. And I'll do the third one down here. So 4 times -1 plus 8. So remember, when we're multiplying with negatives, if these had the same sign, I would get a positive. If they have different signs, like this one does, positive and negative, we will get a negative answer. So this will be -4 and then plus 8. And then we have to add these using the rules we learned earlier. So you could think of these as 4 red chips and 8 black chips, or 4 worms and 8 spiders. We've had all kinds of different ways to think about it. However you do it, it will come out to be +4. So I did these in order. I put in 2, I put in 5, I put in -1, and I got 3 different answers. So all of these are going in just for that x. Okay, so let's look at number 4. Evaluate 5a minus 9 when a is 0, when a is 4, and when a is -3. So all of these are going to go in for a right here. So I'm going to have 5 times 0 minus 9 for the first one. So we did the multiplication first. 5 times 0 is 0. So I'm going to have 0 minus 9. So that's a little confusing. You might be able to figure that out right off the bat. If you don't remember, let's use the rule we did in our integers unit, which is keep, change, change. I'll keep the 0, change the minus to plus, and change that to -9. And I think that makes it make a little bit more sense. So we're adding 0 and -9 together. When you add 0 to anything, you just get -9. Okay? So we did 0. Now I'm going to do 4. So I'm going to put 4 in. So 5 times 4 minus 9. So 5 times 4 is 20, minus 9 is 11. And then there's one more, -3. So I'm going to put -3 in where a is. So 5 times -3 minus 9. So 5 times -3, they have different signs. That's going to make it -15 and then minus 9. So if I do the keep, change, change like I did over here, this would be -15 plus -9. And so we're just adding a whole bunch of negatives together to get a bigger negative answer, -26. Or if you're thinking this would be red chips and red chips, you just get more red chips. Worms and worms, you just get more worms. Whichever analogy you liked when we were doing the integer problems. Okay, and just remember when you're putting the numbers in that we should follow order of operations, which, if you remember right, the first thing is parentheses, then we do exponents, then you do multiply and divide, and that goes from left to right, and then add and subtract from left to right. So those are the rules once you put the numbers in, just like they were when we just had normal things. And so I'm going to keep that up here to do this next section. Oh, if I can keep it on the screen. So in this last part it says evaluate each using the values given. They're going to give us more than one variable. So if we look at the first one, I have 3 plus hj. Use h equals 2 and j equals 4. So they're giving us 2 letters, and each letter has just one value. So the 3 and the plus stay, and then when I hit the h, that's going to be 2. So I'm going to put in a 2. And then when I hit the J, I'm going to put in the 4. We don't have anything to do inside these parentheses. I just added those to show the multiplication. We don't have any exponents, so the next thing we do is multiply and divide. This H and J were next to each other. That means multiplication, so this 2 and 4 are going to get multiplied. That makes 8. And then I can add the 3 to the 8, and we get 11. So make sure that you're following your order of operations. All right, let's look at number 6. I have m squared p. This means m squared times p. We're going to use m equals 3 and p equals 4. So this m is 3 and this p is 4. So where the m is, I'm going to put in 3 and then I'm going to square it. And where the p is, I'm going to put 4. So I have multiplication between the parentheses here, and I also have an exponent. So the exponents are supposed to come before multiplication, so I'm going to do that first. 3 squared, I'll do that here to the side. 3 squared means 3 times 3, which is 9. So we put 9 there, so that's going to be 9 times 4 if I take the parentheses off, and we get 36. Okay, so for number 7, we have b squared plus b minus c. So we have 2 b's in our formula. That's okay. They're both going to be 2. So when I put the 2 in, I'm going to have 2 squared plus 2. And I don't feel the need to put parentheses on that one. And then minus c, which is 1.
We are working. I was just doing that with some of the kids today.